The factored form of a quadratic comes in the form of f of x equals a times x minus p, x minus q. So p and q are both zeros, okay, or x-intercepts or solutions. Now recognize that these are the values being subtracted from x. So when I go to find zeros a little later on, it's going to look like I'm flipping the signs, and that's because of the minus signs here in the parentheses. Alright, and that a value again is how much of the parabola will move up or down when I go 1 unit to the side of the vertex. And if I want to find the axis of symmetry, I'm going to use the formula x equals p plus q all over 2. So let's go ahead and start by graphing. So the first step is to graph the x-intercepts, p and q. Alright, so the x-intercepts, again, are the values being subtracted from x. So here, the x minus 2, it's pretty clear that it's a 2. But when I go to deal with the x plus 4, remember, this is the same as x minus negative 4. So my two x-intercepts are at 2 and negative 4. So I'm going to go ahead and plot those. Don't forget, if you put something on the graph, you need to make sure to label it. The next step is to find the axis of symmetry. Alright, and there's a nice little formula for it. Alright, so here's my axis of symmetry. And I'm going to take my p and q values and add them together. So 2 plus negative 4, and then divide them by 2. So 2 plus negative 4 is negative 2. Divided by 2 is negative 1. Now you can also get this from recognizing that the axis of symmetry is halfway between the points, the x-intercepts. So you can also count the number of boxes that are between the two intercepts and then find the halfway point that way, right? So there's 6 hops, half of 6 is 3, so I could put my axis of symmetry there. The main reason why this equation is useful is because if you have like a fractional kind of response there, sometimes it's hard to tell exactly where your axis of symmetry will be. Our next step is to plug in the x value of the axis of symmetry to find the y value of the vertex. Okay, so here I'm going to find the y value for my vertex. So I'm going to plug negative 1 into my function. So I have negative 1, oh, that didn't look like a negative 1, plus 4 times negative 1 minus 2. Okay, I'm going to go ahead and just start calling this y, even though it's f of negative 1. It's okay, they're interchangeable. So I have negative 1 plus 4 is 3, and negative 1 minus 2 is negative 3. 3 times negative 3 is 9, times another negative, 3 times negative 3 is negative 9, times another negative is a positive 9. So our vertex is at negative 1, 9. So if I go up by 9 hops here on the axis, it's right here. Now remember, when we go to plot or graph a parabola, we usually want 5 points. So this is where I'm going to take advantage of my a value. So the number that's being multiplied here in front of the parentheses will usually tell me how much up or down I move when I move 1 unit to the side. Now I'm going to caveat that with making sure you guys are aware that there's no number in front of the x's here. Okay, so your P and Q values are fractions for this. So here my A value is a -1. So when I go 1 unit to the side, I'm going to fall by 1 unit. See, so this one is at -2, -8, or +8. And this one is at 0, +8. And now I have my 5 anchor points, and I can go ahead and graph my parabola. And there we have it. So that is graphing from factored form.